All right, so today we're working on section 4 of our notes, which is density and displacement. So this first page will cover density. So density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. So D equals M over V, or DMV sometimes is a mnemonic that helps people remember that. D equals M divided by V. What is the density of carbon dioxide gas if its mass is 196 thousandths of a gram and occupies a volume of 100 milliliters? So we don't know density. They gave us the mass and the volume. So we just simply need to divide those. So that's really just going to add 2 zeros in here. Grams per milliliter. Okay, so you take your units divided too. So this would be grams per milliliter. All right, a cylindrical container with a radius of 8 centimeters is filled to a height of 10 centimeters with sulfuric acid. So let's go ahead and use that information to find our volume. So for volume of a cylinder, we have pi r squared times height, which we've learned earlier in our notes. So we would want to use 8 squared times 10. Or 640 pi, and we'll go ahead and leave it in exact form for now. The density of sulfuric acid is 1.84 grams per cubic centimeter. So we'll plug that in for density, and then we're looking for mass, and we know that our volume is 640 pi. So to get our mass, we'll multiply by 640 pi on both sides. And it says to the nearest gram. So we'll go ahead and round to 3,700 grams. Okay. Example 3. The diagram below shows the dimensions of a concrete cylinder. Concrete has a density of 2.3 grams per cubic centimeter. Find the mass of the concrete cylinder to the nearest gram. So it looks like we're doing inches, but then here we have cubic centimeters, so you have to keep an eye on that because we're switching volume units. So let's go ahead and find the volume in inches. We would have pi times 24 squared times 32. And let's leave that in exact form for now. We have 18,432 pi. And that would be cubic inches. 1 inch is about 2.54 centimeters. I think it would actually be easiest if we go ahead and find let's go ahead and convert now. So 18,432 pi is cubic inches. And we know that 1 inch is 2.54 centimeters. But because this is cubic inches, I'm going to want to cube these before I figure out how many centimeters it would be, because then that would be my cubic centimeters. So let's do 18432 pi over x is 1 over 2.54 cubed is 16.39. We'll do 2 decimal places, and now we can cross multiply. So x would be approximately 409,076.65. So this is our volume in cubic centimeters now instead of cubic inches. You could have also converted inches to centimeters at the beginning and then found volume, but you should still end up with this volume. So we want our density to be 2.3, and then we're looking for mass, and then our volume is our long number here. So we'll take that times 2.3. So it looks like our mass would be 2,182,876. Oh. Sorry about that. And it says to the nearest gram, so we would just go ahead and leave it like this, grams. And if you rounded at a different spot, you might be off by maybe you had 75 instead of 76, but this would be our final answer minus maybe some rounding error. All right, last one for this side, and then we'll move on to displacement. Density is an important characteristic of matter that is often used to identify a substance. Each substance has a density that differs from the densities of other substances. Moreover, the density of a substance always stays the same if the temperature and pressure do not change. So for a gold-colored ring that has a mass of 18.9 grams and a volume of 1.12 milliliters, is the ring pure gold? So we're going to find the density and then compare that to the density of gold, which is 19.3 grams per milliliter typically. So it looks like our units are the same, so we don't need to do any conversions. So we'll just go ahead and find the density by taking 18.9 over 1.12. And it looks like we get 16.875. So that would mean that it is not pure gold, because it's not equal to our 19.3 here. All right, moving on to our next page. All right, displacement. To measure the volume of an irregular object, you can use displacement. So for our first example, it's an egg. So really what we're doing here is we're finding the difference in volume to find the volume of that irregular object. By submerging it in water, you can measure the amount of the water rises to determine its change in volume. So here, it looks like let's say this is milliliters. They didn't tell us. We're going to say it's milliliters for our purposes. It looks like, so this would be 5, 6, 7 tenths of a milliliter. And this one would be 1.1 milliliters. So to find the volume of our egg, we would just subtract and we would get 0 or 4 tenths of a milliliter. Okay. So this is already in volume units, so all we have to do is subtract. Now, they're not always in volume units, so you'd be looking for milliliters, cubic centimeters, cubic inches, but sometimes they're just in normal dimensions and we have to do a little bit more work. So you'll see that in example 2 here. It says you drop in a regular piece of metal into a container partially filled with water and measure that the water level rises 4.8 centimeters. Now the key here is that this isn't cubic centimeters, it's just centimeters. It's just the height. So we're also going to have to take into account our width and length. The square base of a container has a side length of 8, so I'm going to do my best to draw a cube here. And it's a square, so these would both be 8. You measure the mass of the metal to be 450 grams, find the volume of the metal, what is the density of the metal, and round to the hundredths place. So if I have 8.8, but my water level is rising, that 4.8, I can find the volume that it was changing by multiplying those 3 together. So I'd have 8 times 4.8. Is 307 and 2 tenths. So now it's in a volume amount. So that was part A, find the volume of the metal. Okay, and then they want us to find the density, and they gave us the mass to be 450. We found the volume already. So our density is 1.46 grams per cubic centimeter. Okay, so really for displacement, just make sure if it's already in volume or if you have to figure out the volume. That's really the key difference you have to figure out here. Example 3, last one for today. The base of a rectangular tank is 3 feet by 2 feet. So let's go ahead and figure out. So not to scale, obviously, but I'm going to try to draw this here. So we'll say this is our 3, this is our 2, and the tank is 3 feet tall. So we have another 3 here. The water in the tank is currently 9 inches deep. Let's go ahead and convert them all to inches so that we're not dealing with feet and inches. So this would end up being 36 by 24 by 36. And our water level is currently at 9. So if I want to figure out the volume of just my water, I would do 36 by 24 by 9 instead of the full height of 36. So let's figure that out. 7,776 cubic inches. We're measuring in inches. All right, it says the water level will rise when a 1-foot metal cube, which is denser than water, is placed on the bottom of the tank. So let's do kind of a bird's eye view of this tank. And what's tricky here is a 1-foot cube is 12 by 12 by 12 if we're converting it to inches, but our water only goes up to 9. So if it was going to be completely submerged, it'd be a lot easier, but this one won't be completely submerged. It'll be potentially sticking out at the top a little bit. So let's do kind of a bird's eye view here. We'd have a 12 by 12 cube, again, not to scale, and our 36 by 24 tank. So like this would be a bird's eye view or just a slice of the bottom. So if I take this area cross section, I would have for my area 36 times 24 minus my 12 by 12. Oops. So let's see what that would be. 36 times 24 minus 144 is 720 square inches. And then I would still have to figure out how much my water is rising. So remember, this is the volume of my water, and this is how high it would go up, like 1 inch depth would be. So really what we want to do here is take our volume of our water divided by our cross-section area, so we can figure out what that new height would be. So if I take my 7,776 divided by that 720, I'm going to get a new height of just 10.8 inches. And then remember, this was cubic inches, this was square inches, so those will divide out to just be inches to the first power. So that's our new height. And then it wants to know the difference in height, so we take our 10.8 minus 9, which is 1.8 inches of rise. All right, so you do have to be careful with thinking about if that cube would be completely submerged or not. If it would be, then you could tackle this problem differently. But we have to take our volume of water divided by our cross-section because it would be taller than the original amount of water.